Today, we're diving into a really powerful but maybe underutilized therapy for one of the most awful injuries you can imagine, a severe burn. And it's a treatment that uses the very air we breathe, just, supercharged, to fight back against the damage. But before we even get into the science, let's just get a sense of the stakes here. Take a look at this number. That is over $1.6 million. And according to the National Burn Repository, that's the average hospital bill for a single patient with really extensive burns. So you can see, this isn't just a medical crisis, it's a huge financial one, which is why we so desperately need treatments that can heal people faster and better. So what actually happens when someone gets a severe burn? It's really easy to just think of it as, a bad skin injury. But the truth is, it's so much more complex. The fire itself is really just the beginning of a crisis that unfolds across the entire body. And this right here is such a critical idea to grasp. The moment of the burn, that's just a single moment. The real cascading damage happens in the hours and days after the fire is out. And it's driven less by the heat and more by the body's own frantic and often self-destructive response to the trauma. This brings us to this invisible internal battle. See, after the burn, the body launches this massive inflammatory response. And it's supposed to help, right? But it can spiral completely out of control, and it becomes the enemy, causing way more damage than the original injury ever did. So, you've really got to think about it in two parts. On the left, you've got the burn itself. Okay, but on the right, that's the real threat. This massive body-wide swelling called edema, and a total shutdown of the circulatory system on a microscopic level. The body is just flooding the area with fluid, but the plumbing, all those tiny blood vessels, they get all clogged up. And this is the battleground. In every burn, there's a central area that's just dead tissue, but all around it is this critical zone of stasis. This tissue is hurt, it's starving for oxygen, but it's still alive. For the next 24 to 48 hours, this whole zone is on a knife's edge. It can either live or die. And saving this tissue, that is the absolute key to stopping the burn from getting worse. What you're looking at here is basically a biological traffic jam. The body's own inflammatory response creates these tiny blood clots and swelling that just completely block the microscopic capillaries. So it doesn't matter how hard the heart is pumping, oxygen and nutrients just can't get through to that tissue we need to save in the zone of stasis. It's literally suffocating. Let's zoom in even closer. So, on the left, that's the smooth, tight lining of a healthy little blood vessel. But now look at the right. Look at the chaos after a burn. The body's own white blood cells and platelets are sticking to the walls, the lining gets all leaky, and these microclots start to form. This is exactly why that traffic jam happens, and it's what turns an injury that could heal into a dead zone. So, if the main problem is a lack of oxygen, what if we could just force it to where it needs to go? Well, this is where the hero of our story comes in, hyperbaric oxygen therapy, or HBO2. And it's a surprisingly simple solution to this incredibly complex problem. So what is it exactly? Well, the idea is pretty simple. The patient just lies inside a special chamber where the air pressure is cranked up to 2 or 3 times what's normal. And while they're in there, they breathe 100% pure oxygen. It's that combination of pressure and pure oxygen that works the magic. And here's the genius of how it works. Under all that pressure, huge amounts of oxygen dissolve directly into the liquid part of your blood, the plasma. Now this is the key. It means getting oxygen to your cells is no longer all up to the red blood cells, which remember are stuck in that biological traffic jam. This super oxygen-rich plasma can literally seep right through the blockages, reaching those starving tissues in the zone of stasis and basically bringing them back from the brink of death. Okay, so that sounds amazing in theory, right? But does it actually work in the real world? Let's take a look at the evidence, because for decades, researchers have been documenting just how effective this is. First up, let's talk about that massive swelling, the edema. This chart shows a study of really seriously burned patients. The group that didn't get the therapy gained about 17% of their body weight in just fluid. But the HBO2 group, only 9.6%. That's a 45% reduction in that dangerous fluid buildup. That's a huge deal for relieving pressure on organs and tissues. And what does saving all that tissue actually mean for the patient? Well, it means fewer trips to the operating room. One pivotal study found that patients who got hyperbaric oxygen needed 54% fewer surgeries. Just imagine that, cutting the number of painful, risky operations for things like skin grafts by more than half. That is a monumental difference. And the benefits just keep stacking up. When you heal faster and you avoid all those extra surgeries, you get to go home sooner. In that same study, patients getting HBO2 therapy were discharged an average of 12 days earlier. That's almost 2 weeks of their life they get back, recovering at home with their family instead of in a hospital bed. Now, let's circle all the way back to that staggering number we started with. Fewer surgeries and shorter hospital stays, that has a direct impact on the final bill. The data shows an average reduction in the total cost of care of about 36%. For an injury that can cost over $1 million, that is a massive, massive saving. But honestly, let's put all the numbers and charts aside for a second. This is what it's all about. On the left, you see a horribly burned hand when the patient was admitted, and on the right, that is the exact same hand just 25 days later after treatment that included hyperbaric oxygen. It's healed, it has full function, and, this is so important, it healed without needing complex skin grafting. This is the human side of getting oxygen where it needs to go. So, after seeing all of this, you have to ask the obvious question. If this therapy can reduce swelling, save tissue, cut down on surgeries, shorten hospital stays, and slash costs, why isn't it just a standard part of care in every single burn center? And it's not because the proof isn't there. I mean, just listen to this quote from a leading medical journal. The scientific community has been building this really strong case for decades. The experts in the field, they know it works. The real challenge is kind of baked into how we prove things in medicine. The absolute gold standard is this massive, multi-center, randomized trial. But for an emergency trauma like a severe burn, those are just incredibly difficult and expensive to pull off. You've got ethical questions, tons of patient variables, huge logistical nightmares. So even though we have lots of smaller studies show these amazing benefits, that one single definitive trial has just been elusive. And that leaves us with a really critical question. We've got decades of positive data. We have these compelling before and after pictures. We have the word of skilled doctors who see it working with their own eyes. So when you're facing an injury this devastating, with consequences that can last a lifetime, maybe the real question is, should we be waiting? Or is it time to act on the overwhelming evidence we do have and make this potentially life-changing therapy available to every single patient who could benefit from it? It's something to think about.